Okay, my name is Shaun Burnie. I'm a senior nuclear specialist with Greenpeace, East Asia. I've been working with Greenpeace on and off for about 30 years. And one of my areas of focus is the situation in Japan, working both on the legacy of the Fukushima disaster and overall energy policy, basically trying to convert Japan from nuclear and fossils to renewables. And thank you very much for the opportunity to talk today. I know that you'll be getting into a lot more detail with some of the presentations later on. So I'd just like to give an overview as to some of the main issues that we found from our survey work in Fukushima. So Greenpeace has been surveying in Fukushima since March 2011. We were on the ground in Itate and in Namie around the 26th of March, so just under 2 weeks from the start of the disaster. I won't be talking about the current situation at the Fukushima Daiichi plant, but this is just to give you a sense as to what the current situation looks like at the plant itself. Obviously, there's about 4,000 workers on site doing daily work. Most of these are subcontractors, not TEPCO employees. 3 reactors melted down, obviously, as we all know. About 1.23 million cubic meters of contaminated water, which the Japanese government wishes to discharge into the Pacific Ocean. And obviously the main radiological hazard in Fukushima is what is on the site, including the molten cores in the 3 reactors. The estimates are between 600 and 1,100 metric tons of molten fuel. Current decommissioning plan is for everything you see here to be demolished and packaged and removed from Fukushima within the next 30, 40 years, by the mid-2050s at the latest. None of that is credible. And pretty much everything is likely to remain in Fukushima prefecture on this site for the coming decades, centuries and beyond. So in terms of the presentation for today, I'd just like to talk about the situation away from the nuclear plant itself. The area that we're talking about is specifically the special decontamination area, which is the area marked in the orange area, which includes Okuma and Futaba. That's the 2 districts closest to the Fukushima Daiichi plant, as well as other areas such as Namie and Itate, also bits of Katsurao. And since 2012, the Japanese government has initiated an enormous decontamination program. This is intended to remove the cesium concentration, which deposited on the land in and around Fukushima, but also further away. In fact, if you look at this map again, the reason that this area is moving to the northwest of Fukushima is entirely due to the radioactive fallout that took place, particularly around March 13th, 15th, 16th of 2011, because the wind direction was blowing in northwesterly, basically moving radioactivity from the Fukushima Daiichi plant west and north towards Itate. So in fact, the 20-kilometer exclusion zone that existed around Fukushima Daiichi was not sufficient because of that radioactive fallout. And so you have areas such as Itate, which stretches 30 to 40 kilometers from the Fukushima Daiichi plant itself. So the decontamination program, which began in 2012, is sort of unprecedented in scale. As of March 2019, cost around $28 billion, generating 17 million tons of nuclear waste. All of that material is located in Fukushima prefecture. They are moving it to interim storage sites near the Fukushima Daiichi plant, which means hundreds of nuclear transports every day. Currently, it's located in about 50,000 sort of temporary and interim storage sites located across Fukushima prefecture. Ultimately, all of that material is to be stored only for 30 to 40 years, and then it all has to be removed. The reality, of course, is it's going to be remaining there for a very long time. In the special decontamination area, there was about 9 million tons of nuclear waste costing about 12 billion euros. So the decontamination, which has been the main focus of Japanese government's communication to the people of Japan, is that we've initiated this enormous program and we've reduced radiation levels. The reality, of course, is very different. But what the Japanese government has attempted to do is to communicate to the people of Japan that even with this triple reactor meltdown, decontamination is possible. And they use language such as decontamination has been completed, whole area decontamination was completed on March 19th, 2018, except in these so-called difficult to return to zones. So what does that all mean? Greenpeace, as I said, have been surveying since 2011. In particular, from 2015, we developed a program to investigate contamination in the mountainous forested areas around houses and streets in areas such as Itate and Namie, but also in the exclusion zone of Okuma and also Fukushima City. We've conducted tens of thousands of measuring points in each of those locations, both in the areas where evacuation orders have been lifted, but also areas which are still designated as difficult to return to zones, or so-called exclusion zones. Access to those areas for survey work has been entirely as a result of the assistance of evacuees from Fukushima. Just to give you an idea of the sort of decontamination work we're talking about, this is in Obori, on the border of the exclusion zone and the open areas of Namie. And what you have basically is workers on a daily basis moving nuclear waste to all different parts of Fukushima, and particularly to Namie, Okuma, and Futaba. So the scale of this is really hard to grasp until you've actually been there or at least seen the images. And the aim of the Japanese government was to reduce the concentrations of cesium so that the surface dose area that was measured was less than 0.23 microsieverts per hour. And in many cases, they have reduced those air dose levels. But as we'll see, that's not the complete story. And in fact, the 0.23 microsieverts per hour limit is a long-term target for which they've actually not given any time frame as to when they will reach that. The reason that they opted for the 0.23 microsieverts per hour was that they calculated that based upon 8 hours per day living outside or working outside and 16 hours inside, that would give you your maximum permissible dose of 1 millisievert per annum. But as you'll hear later on today, the Japanese government doesn't have a 1 millisievert per annum for Fukushima. It sets at 20 millisievert maximum per year. So in our survey work, we measure at 1 meter and when we're measuring for hotspots, 10 centimeters. But all the measuring data that you see here is measured at 1 meter, both from vehicles and also on foot. So basically in the areas that we're talking about, we have the Namie, so-called difficult to return to exclusion zone. And there we're measuring maximum levels up to 24 microsieverts per hour with an average of 4 in the district of Obori. Burnie was one of the most contaminated areas. It lies about 20 kilometers, 8 to 20 kilometers from the Fukushima Daiichi plant. But as you'll see in the column for averages, they're all well above 1 microsievert per hour. If you look at Namie Takase River, this is an area where the evacuation order was lifted in March 2017. In Namie itself, there was about 21,000 people in 2011. The current numbers are around 1,200, so most of the population still is displaced. This is an area where the government opened and said we've completed decontamination in March 2017. 1 year later, we were still measuring an average of just under 2 microsieverts an hour. Pretty much all of the areas were above 0.23, the government target. The same applies at a local school and kindergarten, which is more in central Namie town, with an average of 1.8 microsieverts an hour, a maximum of 2.9. And then finally, one of the areas we've focused a lot on is in Iitate, which is about 32 kilometers from the Fukushima Daiichi plant. There, the average was 0.7 microsieverts in 2018, with a maximum of 1.7. It's important to remember that the general background radiation levels in Fukushima before the accident in March 2011 was 0.04 microsieverts per hour. So just to give you a sense of Iitate, as I said, about 35 kilometers from the Fukushima Daiichi plant. It was one of the last areas to be evacuated. Initially in 2011, the population, which was about 6,100 people, it was outside the 20-kilometer exclusion zone. Greenpeace went there in March 26. On the 28th of March, we called for an immediate evacuation. The government didn't finally pass make a decision until mid-April 2011, and there were still around 1,000 people still living in Iitate as of June 2011. So it's the most exposed population in terms of overall contamination from Fukushima. So what we tried to do is understand what the radiological situation is within a certain number of locations. It's obviously impossible to conduct detailed survey of everywhere in Fukushima, including in Iitate. So this is the house of Mr. Toru Anzai, who evacuated finally in July 2011. We divided up the area around the house into a number of zones, and basically that allows us to conduct survey work on a grid pattern. Since 2015, we've collected data, and we'll be publishing our latest survey results in early March of this year. This is a table from last year, so it covers the period 2015 through to 2019. Basically, you'll find that in nearly all areas of the zones around Mr. Anzai's house, the levels are above 0.23 microsieverts. If they're not, they're 98%, 99%. And yet this was an area around the house which was heavily decontaminated, particularly in the period 2015 to 2016. And there are some very specific radiation readings around this house that highlight the broader problem of contamination and decontamination. So in 100% of 7 of the 10 zones, still exceeded the 0.23 microsieverts per hour target. In 2019, zone 5, which is an area behind the house in the forest, the average levels were 0.9 microsieverts per hour, with a maximum of 1.3. This compared with 1 and 1.7 the year before in 2018. The radiation levels on the slopes directly behind the house are crucial, as we've measured in the past that they have a direct impact on radiation levels inside houses due to the gamma radiation, which of course passes through the thin walls of the houses. Between 2018 and 2019, in 2 of the zones, we found a significant reduction over the year before. So for example, there were 68 and 58% of the levels 1 year previously. And based upon how stable radiation levels generally are, this cannot be explained by radioactive decay alone. And one of the big factors that we found in October 2019 was that the whole region, the whole of Japan, had just been subjected to this enormous typhoon, Typhoon Agibas, where up to 800 millimeters of rain fell within a 24-hour period. And the question, which had already been raised by scientists and ourselves over the last years, was that, in fact, Fukushima forests were subjected to enormous weathering effects, which led to increased radioactive material moving down through the water system into different parts of Fukushima and eventually into the Pacific. So one of the main narratives of the Japanese government, as mentioned, is that they have completed decontamination. And the reason for this language is to try and encourage the population to return to their former homes. There's about 165,000 people were evacuated directly as a result of the nuclear disaster. There are no real accurate numbers published on evacuees as of today. The official evacuee numbers are in the 40,000 level, but that does not include the so-called self or voluntary evacuees, which in 2017 was just under 30,000. Those numbers no longer exist. The official recording of voluntary evacuees was terminated in 2017. But the Japanese government is desperate to try and get population numbers back to some sort of normality to which the levels they were in 2011. We'll talk a little bit about how successful that is, but one of the main ways of doing that is to communicate that decontamination has been successful and decontamination has been complete. We'll be publishing numbers which we've calculated in our next report, but this is a figure from Itate. The total area of Itate, we estimate 79% of it has not had any decontamination work done whatsoever. The reason for this is that out of the total area of 23,000 hectares, only 4,800 hectares have actually been officially decontaminated. And these are numbers from the Japanese Ministry of Environment. And therefore 18,000 hectares have not had any decontamination. Those numbers do not include houses in Itate, because the government doesn't give house decontamination in hectares. It's not really possible to calculate what that is, but the contribution of houses to the overall surface area is negligible. So in this case, Itate, just under 80% of the whole district has not had any decontamination done whatsoever. And given that most of this region is forested mountains, it's obvious the radioactive material that was deposited in 2011 is going through natural cycles, going through decay, but the majority of it is still there. If we take another area, which is the Takasa River, which flows through the open area of Namie and then into the Pacific. Again, this is an area where evacuation orders was lifted in March 2017. Again, radiation levels are consistently above the government target. Along the riverbank and road, which is publicly accessible as of March 2017. In 2018, we measured an average of 0.8 microsieverts with a maximum of 1.7 microsieverts. So these levels are 20 times higher than the previous levels before the accident in 2011. And of course, we find radioactive hotspots in these areas quite consistently. As you'll know, because of COVID, the 2020 Summer Olympics did not take place, and they're currently planned to take place in the summer of 2021. Whether they do or not remains to be seen. Because of the decision to host 2 Olympic events in Fukushima prefecture, and also to start the torch route, Olympic torch route in Fukushima prefecture, we surveyed in and around both the Olympic venue and the torch route in October, November 2019. This is the Azuma Stadium in Fukushima City, about 80 kilometers from the Fukushima Daiichi plant. We also surveyed at the J Village, which is to the south of Fukushima Daiichi, where we basically took measurements along the area where the torch route would actually begin. As you can imagine, Fukushima City was subjected to enormous decontamination program in 2011, 2012. We can still, however, detect radiocesium. In the Azuma Stadium itself, the average levels were 0.1 microsieverts an hour, so below the Japanese government target level. We would expect that, given that this is an Olympic venue, it's relatively flat, so it's not subjected to so much recontamination. Nonetheless, the levels were still 2.5 times higher than what they were in 2011. Again, Fukushima City itself, the average 0.1 microsieverts with a maximum of 0.2. These are all measuring points. Again, 2.5 times higher than March 2011. The main issue, therefore, we conclude is not for spectators or visitors, tourists, and certainly not athletes who would be coming to Fukushima for the Olympics, but largely it's an issue for long-term residency, the citizens of Fukushima who are living there. The situation is very different at the J Village, which was the planned start of the Olympic torch route in March 2020 and remains also the planned start location for the 2021 Summer Olympics. It's about 20 kilometers south of the Fukushima Daiichi plant, was not subjected to the highest radioactive fallout in March 2011, but still we find radioactive cesium at this location. So in October, November 2019, we went to this area with the aim of trying to understand, okay, this is the start of the torch route. What levels of decontamination have been conducted and how radioactive is the environment at what is to be the most famous, at least in March, start of the Olympics for Japan. And given that the Japanese government's narrative is to say that everywhere it's being decontaminated, where people are able to live, where people will be encouraged to return home, and where we're starting the Olympics, you would expect radioactive cesium levels to be at least below the government target level, if not much closer to what they were prior to 2011 accident. So this is a car park area in the center of J Village, where you didn't really expect to find levels that we found. And what we found was up to 73 microsieverts per hour, which is about 1,750 times higher than what they were back in 2011. We informed the Japanese government confidentially in late November of 2019. These were levels that were clearly not safe from a direct public health exposure. There were thousands of people at this location in J Village when we were surveying. And so the Japanese government really didn't acknowledge what we were saying, what the results of that survey were. But in early December, they sent TEPCO to decontaminate. But again, only a few meters was actually removed. And when we measured again, the levels were about 1 microsievert per hour at 10 centimeters. But on that same day, in late December 2019, we still found radioactive hotspots, 2.2 microsieverts at 10 centimeters, 2.6, at 10 centimeters next to the parking lot and also in a forest. So clearly there's an issue here which these radioactive hotspots highlight, which is that there is nothing normal about the radiation levels in significant areas of Fukushima prefecture. So what can we conclude from our survey work? The main one is that the radioactive cesium that deposited in Fukushima in March 2011 is a long-term source for downstream contamination. It's highly complex. You see over the years quite stable levels, levels that are entirely down to radioactive decay. Cesium-134, for example, is largely negligible at this stage. So the dominant cesium-137 is remaining in the environment 10 years after the accident. That's to be expected. But there are also significant variations, particularly in the forested uplands. And over 70% of Fukushima prefecture is forested mountainous areas. And what we've seen over the years is that when these areas are impacted by heavy rains, such as typhoons, it can increase the cesium discharge rates from the forests by 1 or 2 orders of magnitude. What our survey work has found is that in areas where the government lifted the evacuation order in March 2017, for example, in Iitate and Nami, the radiation levels remain significantly above the long-term target of 0.23 microsieverts an hour, or 1 millisievert per annum. And therefore, the whole basis of the Japanese government's argument, which is that decontamination is being completed, has no basis in reality. The consequence is that the lifting of evacuation orders for these areas and the deliberate policies of the Japanese government, where they're coercing citizens to return to their former homes, means that there are multiple violations of Japan's obligations on human rights, most especially for children, women, and workers, but also for the broader adult population. In terms of our recommendations, obviously the current policies of effectively forcing citizens to return is not based upon a science-based analysis, but and ignores the long-term exposure risks. The Japanese government has failed to clarify its long-term decontamination target as to when population living in these areas of Fukushima would receive their maximum of 1 millisievert per annum. There's no time frame for that. And until they clarify that, their policies of lifting evacuation orders have no justification. Our recommendation is to abandon plans to continue to lift evacuation orders in such areas as Futaba and Okuma and Nami and Iitate, to instead provide full compensation and financial support for evacuees, and to base their overall approach to radiation exposure based upon science and the precautionary principle to protect their citizens, and to allow them to make free choices as to whether they return to these areas. And finally, not to continue to ignore the continued intervention of United Nations Special Rapporteurs on Human Rights, including requests for actual visits to Japan so they can actually assess the situation on the ground. And with that, I'll finish now and I'll be happy to take questions.